calcium carbonate. Calcium oxide 40.1 plus 16. 56.1 for calcium oxide and 40.1 plus 12 plus 16 into 3. 100.1 for this. 1000 divided by 205. 756. 1.7. What is total mass of carbon dioxide? Sir, answer नहीं आ रहा.
And this one is so easy that you don't even need to pick up the calculator. Okay, I'm going to show you something. Since I said that write the equation, the balanced chemical equation, and if you go with the number of moles, this is going to be really difficult. This is 1 mole, this is 1 mole, this tells us 1200 million tons. And since this is mass, the moles and the mass ratio won't work. We need to find out the MR. Now the MR for this one is 100 and this one is 44, right? And how many million tons do we have? This one and this one is 1000 plus 200, so that's 1200, right? So if it's 144, it's 1200 ratio x. And before you pick up the calculator, now, if it was just 1000, as per 44, it has to be 440. So it can't be 440 since it's 1200 and not 1000. Now, since 44 is less than 50%, the 50% of 1200 is 600. So it can't be 660 and 880. So definitely this is the answer without calculation. Make sense?
Yes, sir.
So you don't even need to pick the calculator up. You can even do it in mind, all of this in mind. So this is the MR versus MR ratio. And whenever, remember, I told you that this ratio method, or which we have been calling metric method all along. So metric method works great if you have masses all along. So since everything over here is in masses or MRs, so the calculation should be easy. So if you calculate X, that is going to be 44 into 1200 and divided by 100. So yeah, that's easy. And that's 44 into 12, which is 528. Again, which is pretty easy. Get the point?
Yes, sir.
Good, good. Number 3.
In group 2 of the periodic table, properties of elements and their compounds show regular change down the group. Which property shows a decrease from magnesium to barium? Magnesium to barium, the decomposition temperature of the carbonates, the decomposition temperature of the nitrates, the solubility of hydroxides, the solubility of sulfate. Solubility of sulfate decreases. D.
You said D. D is in door, right? Right?
Yes, sir.
Yeah, that is correct. That is correct. I was actually confused whether you said B or D. Okay, number 4.
Which compound would most usually be added to soil to reduce its acidity? Aluminium hydroxide, calcium hydroxide, magnesium hydroxide, sodium, calcium B.
Right. Okay. So number 5.
River water in a Turkey agricultural area contains calcium, magnesium carbonate, hydrogen carbonate, chlorine, and nitrate ions. In a water treatment plant, such water is treated by adding a calculated quantity of calcium hydroxide. What will be precipitated from the river water following the addition of calcium hydroxide? Contains ions. In a water treatment plant, such water is added by calculated quantity of calcium hydroxide. What will be precipitated when we calcium hydroxide? B. B for
Yes.
ball.
Yes, that is right. Next.
Sir, but how we were to copy here?
Don't you remember? Okay, this is back from IGCSE. River water in this area contains all of these ions. In a water treatment plant, such water is treated by adding this quantity of calcium hydroxide. What would be precipitated out? Now, in the presence of calcium hydroxide, these ions actually react and form calcium chloride, right? Why? Because those areas are acidic. When that happens, and let's clarify. And since we are going to have a good quantity of these ions, or probably, if not these ions, right? So in the presence of these, plus since the soil is acidic, now this and this part is going to form H2O. These and these are going to form this, right? So this is your answer. Okay. Now the question arises: there are other negative ions are there as well. For example, chloride. For example, nitrate. Understandable, which may form this, or this. Understandable. But remember, calcium chloride is soluble. Calcium nitrate is also soluble. Actually, all nitrates are soluble. So is this one. But they are talking about a precipitate. So anything that is insoluble is this. Now, if you don't know any of this, just from the word precipitate, you can only get this answer. This cannot precipitate, this cannot precipitate, this cannot precipitate. You know why?
Yes.
Because they're all soluble. So this is understandable. B was the only answer. There are many perceptions for which we can go to find out the answer for.
Yes, sir.
Okay, moving on.
The 3
We
minutes
are done with this one, right?
I guess.
A Pareto question was already there in the previous part.
Yes.
Yes, so you would easily be able to do it. Let's not go with that. Okay. This is also something you're done with. Let's go with 8.
The diagram
8
shows
is
some
something you are already done with as well, but it's a little bit challenging because it actually asks you to ponder on the question. So go ahead with it.
The diagram shows some applications of compounds of group 2 elements. Which numbered lengths are correct? Calcium carbonate, magnesium oxide. Calcium carbonate used as a refractory lining in furnaces and ovens, used as a building material, used to manufacture an agricultural chemical to adjust soil pH. And magnesium oxide. Used to manufacture and agriculture, chemical to adjust soil pH. Calcium carbonate reduce soil acidity. Calcium carbonate. Used as a building material. And then 5 and 6. 4 and 5. 1, 2, and 3. Calcium carbonate is used as a building material, so 2 is correct. It is used to manufacture and agriculture, chemical to adjust soil pH. 3 is also correct. 2 and 3. And then magnesium oxide. 6 का तो नहीं सही. 4. C.
Good. 2, 3, and 4 are correct, which makes C the right choice. All right, let's move on. Okay, number 9.
Which which statement concerning calcium hydroxide?
Too easy. Number 10. You would easily be able to do it. Let's go with number 10.
Solid barium oxide is added to some aluminum sulfate solution in a test tube and the mixture is warmed. A piece of damp red litmus paper is held over the mouth of the test tube. Which observations would be made? Solid barium oxide is added to ammonium sulfate solution in a test tube and the mixture is warmed. Piece of damp red litmus paper is held over the mouth. Damp litmus paper initially turns from red to blue. White precipitate forms in the test tube. Barium sulfate. 2 is correct. And then a brown gas is evolved with strong heating. Brown gas is evolved during strong heating. Barium sulfate is insoluble. Baki ammonia. Ammonia is not brown. I don't think this is correct. Damp litmus paper initially. Yes.
Continue.
1 and 2, B.
Very good. 1 and 2, B. Okay, just a minute. 11. It's a good one. Go for it.
Solid X, Y, W, X, Y, and Z are compounds of 2 different group 2 metals. Some of their applications are described below. Compound W is used as a refractory lining material in kilns. Compound X is used as a building material. It can also be heated in a kiln to form compound Y. When Y is hydrated, it forms compound Z, which is used agriculturally to treat soils. Which statements about these compounds are correct? Okay, compound W is used as a reference calcium carbonate. Compound X is used as a building material. So this is magnesium oxide. It can also be heated from compound Y. It is hydrated. It forms Z, which is used agriculturally to treat soils. Which statement was these compounds are correct? More acid is neutralized by 2 grams of X than by 2 grams of W. The MR of X is greater than the MR of Y by 44. MR of the metallic element in Y reacts with cold water more quickly than the metallic element in W. W is calcium carbonate और Y क्या है? Compound X, which is magnesium oxide, is used as a building material. It can also be heated to form compound Y. Heated to form magnesium oxide. Magnesium plus नहीं. Calcium carbonate. Compound X is calcium carbonate. And compound W is magnesium oxide. So when calcium carbonate is heated, it forms calcium oxide, carbon dioxide. When Y is hydrated, it forms compound Z, calcium oxide, which is used agriculturally to treat soils. So the metallic element in Y reacts with cold water more quickly than the metallic element in W. Yes, 3 is correct. The MR of X is greater than the MR of Y by 44. X is calcium, it is MR of Y by 44. Calcium carbonate का MR metallic element calcium oxide का greater by 44. 100, and then I think this is 56. I don't think this is correct. More acid is neutralized by 2 grams of X than 2 grams of W. More acid is neutralized. More acid is neutralized by 2 grams of. How do we know? C is correct. So it can either be A or C. Now, MR of X is greater than MR of Y by 44. 5. When Y is hydrated, it forms compound C, which is used agriculturally to treat soils. Y is hydrated. I think C.
Well, you're right with C, but I would say that you are actually trying to make a guess about 1. You're pretty sure about 2 and 3, but you are trying to make a guess for 1.
Yes.
Why do you think 1 is incorrect? Before I tell you the exact reason. Okay. Now, first thing first, you're good with all compounds. This one is MgO. This one is definitely CaCO3. And then if we heat it up, this would give us CaO. And of course, if we hydrate it, this would be CaO twice. Now, if you look at it, they are talking about X, 2 grams of X, more acid is neutralized by than 2 grams of W. All right. So we're comparing this and this. So the ACO3 plus HCl gives you CaCl2 plus H2O plus CO2. On the other hand, MgO, it's about W and X, right? So MgO plus HCl gives you MgCl2 plus H2O. Now 2 and 2. So what makes you think 2 grams of X would neutralize more acid than 2 grams of W? If I write the equations for you, what makes you think you're right? You are right, but I want you to go ahead and reason it when you have the equations in front of you. Before I do it for you, of course.
Reactivity?
No. Be a little quantitative.
Carbon dioxide gas.
Be a little quantitative. Quantity, talk about quantity. They're talking about 2 grams and 2 grams. So your logic, your argument as per reasoning should be quantitative too. But number of moles is not going to cut it. Definitely we need to talk about the quantity of something else, since both requires 2 moles of HCl for a balanced chemical equation.
Yes.
Come on, this should be easy. Still lost?
Same reasoning. 2 grams of HCl. No, 2 moles of HCl.
No, actually, keep something in mind. We recently talked about the MR of CaCO3 being 100, but if you calculate this one, you'll reach at a point of 40 MR for this one, right? Since the MR is smaller, if we take 2 grams of it, how many moles will we wind up with? If we take 2 grams of this, how many moles would we wind up with? This would be 0.02. On the other hand, this would be 0.05.
Yes, sir.
Which brings a huge difference. So of course, if we have 0.05 moles of MgO, they are going to actually neutralize 0.1 mole of acid. On the other hand, if we have 0.02 moles of it, this is only going to neutralize 0.04 moles of acid. So which one neutralizes more? Definitely X.
Yes,
Remember,
sir.
higher the MR, lower the quantity it's going to neutralize. Lower the MR, higher quantity of acid it is going to neutralize. This should make sense.
Yes, sir.
Does it?
Yes.
Okay, good. Too easy. No, let's not go with this one. Yeah, let's go with this one. I'm not saying it's too difficult, but it's definitely going to ask you to think, at least twice.
A farmer added lime to damp soil, followed by the nitrogenous fertilizer ammonium sulfate. A chemical reaction occurred in the soil. Which substances were formed in this reaction? Sulfuric acid, calcium sulfate, ammonia. Added lime, calcium oxide plus ammonium sulfate. No. A chemical reaction occurred. Calcium sulfate, ammonia. Sulfuric acid. Sulfuric acid. 2 and 3 C.
Just a second, let me see. So 2 and 3, C. Correct. Okay, 14.
The rock dolomite is a double carbonate of magnesium and calcium. When heated strongly, a product called calcined dolomite is formed, which is used to line some metals. Why is calcined dolomite used for this purpose? Material, it will absorb acidic impurities in metallurgical processes. It will reduce metallic oxides to metals. the rock dolomite is a double carbonate of magnesium and calcium. So it is a refractory material, ठीक है. It will absorb acidic impurities in metallurgical processes. Acidic impurities manufacture. Since calcium also there, so I think 2 is also correct. It will reduce metal oxides to metals. Metal oxides to metals. For this purpose, used to line some furnaces for the production of metals. It will reduce metal oxides to metals. Metals are good reducing agents. Reducing agents, okay. Oxidize. Reducing agents of aggregates are much reduced. A.
No, it's not A. One of these is incorrect. By that I mean also not D. So choose something
B.
in between D and C.
B.
D. So you're trying to say 3 is incorrect. How? First, you're right, it's B. So why is 3 incorrect?
It will reduce metal oxides to metals. It will not reduce metal oxides to metals.
Yeah, now this is a big point. In order to reduce metal oxides to metals, we need good reducing agents. Now, good reducing agents would not be basic oxides. They certainly can't do the trick. All right? Consider this. You remember metal oxide, iron trioxide, which we have been talking about since IGCSE, and we can reduce it. See, we have a neutral oxide that does the trick. We have a good reducing agent that can does that the trick. But if you have this one over here, that's definitely not going to do the trick.
Yes, sir.
Okay, so I hope this clears it out. Okay, multiple topics.
Wow.
Here comes some pondering questions. Number 1.
Compound T is a white crystalline solid. When a sample of compound T is mixed with sodium hydroxide and heated, a gas is produced which turns damp red litmus paper blue. Further testing of a solution of compound T with aqueous barium chloride produces a dense white precipitate which does not dissolve when dilute hydrochloric acid is added to the mixture. What is the identity of compound T? Compound T is a white crystalline solid. अमोनियम कार्बोनेट सोडियम कार्बोनेट तो नहीं हो सकता, सोडियम सल्फेट भी नहीं हो सकता, hopefully. When a sample of compound T is mixed with aqueous sodium hydroxide and heated, when a sample of compound T is mixed with aqueous sodium hydroxide and heated, a gas is produced which turns damp red litmus paper blue. Further testing of the solution with aqueous barium chloride produces a dense false. Further testing of solution of compound T. अगर अमोनियम कार्बोनेट होगा तो अमोनियम क्लोराइड produces a white precipitate, but I think ammonium chloride dissolves when added to hydrochloride. Ammonium sulfate added to barium chloride produces ammonium barium sulfate and ammonium chloride. Red litmus paper, blue. Ammonium carbonate, ammonium sulfate. B.
B. Very good. Let's come to number 2.
A student investigates calcium nitrate crystals by heating them in the apparatus shown. A colorless gas leaves the apparatus at Y. Colorless gas. A flame is held to this gas. Which observations would the student make? Calcium nitrate crystals by heating them. Which observations would the student make? Litmus solution. Calcium nitrate. Calcium oxide plus nitrogen dioxide. Limit Y. Lighted splint. Water with a fluid of surface. Calcium oxide changes to blue. Flame burns. Flame burns. Flame burns more brightly. A.
What if I tell you it's not A, but you're right with flame burns more brightly?
So C.
Now, why is it C? Why does the litmus solution changes to red?
Calcium nitrate crystal.
Now, you're making a very small mistake in this one. You're ignoring a fact that you must think of. Okay, the mistake you're making, I'll explain. The mistake you're making is that you're thinking that calcium oxide would pass on to the beaker and would turn the whole solution alkaline, which would change the color of the litmus to blue. That's not true. Why? Because calcium nitrate is solid as well as calcium oxide. What can pass on to the other side through the delivery tube must be a gas. Now, there are two gases being made over here, oxygen and nitrogen dioxide. Oxygen is not going to bring any difference to the acidity or salinity of the solution, but the pH change definitely is caused by NO2, which is an acidic gas. So the litmus color changes to red. Make sense? However, some of the
Yes.
oxygen will do rise up, and hence the lighted splint, hence the flame burns more brightly.
Yes, sir. Okay.
Okay, good. So number 3.
I think we're done with this.
Yes, we are.
Uh,
Number 4.
Solutions P and Q each contain a different group 2 ion at the same concentration. One contains magnesium ion, the other contains barium ion. Tests are carried out on separate 5 cm cube samples of P and Q. Test 1, add 1 cm cube of 0.1 mole per decimeter cube sodium sulfate. Test 2, add 1 cm cube of 0.1 mole per decimeter cube of sodium hydroxide. What are the results? Solutions of P and Q contain each of 2 different ions. One contains magnesium. Tests are carried out 5 cm samples. Add 1 cm of eventually 0.1 sodium sulfate. Magnesium sulfate and barium sulfate. Solubility of sulfates decreases down the group. So magnesium sulfate would be more precipitate with magnesium, more precipitate with magnesium. And solubility of hydroxide increases down, so more precipitate with barium. more precipitate with barium. C.
Just a second. I don't think it's C. Just a second. More precipitate with Mg2 positive. No. Think again. It's not C. It's either B or D. It can't be C.
D or B? B for ball?
It can be either B or D. It can't be A or C.
Yes, so B, ball.
B. Very good. Now, why do you think B is correct?
One. Solubility of sulfates decreases down the group and hydroxides become more soluble down the group. So something related to that.
Okay, good, good. So, since we are already done with 5, so 6. Let's start with 6.
An ore contains magnesium carbonate and barium carbonate. A sample of the ore is dissolved in nitric acid. How could the solution be processed into a magnesium compound and a separate barium compound? Magnesium contains magnesium carbonate and barium carbonate. A sample of the ore is dissolved in nitric acid. Magnesium nitrate. How could the solution be processed? In a separate barium compound. I feel like C is correct.
And you're right. Let's move on to 7.
When calcium and calcium hydride react separately with water, they each produce a white solid and a colorless gas. The white solid is the same compound in each reaction. Which statement is correct? When calcium and calcium hydride react separately with water, each produce a white solid and a colorless gas. The same compound in each reaction. Calcium plus water, calcium oxide. Plus H2. And white solid and a colorless gas. Both calcium and calcium hydride produce H2. Both calcium and CaH2 produces O2. Calcium produces H2 and CaH2 produces O2. Calcium produces O2. A.
A. That is right. Number 8. Actually, no, that's too easy. 9 is also easy. 2 is 10. We have all easy questions. 11. Let's go with 11. At least something we have is a little bit challenging.
A solid T was placed in an excess of the liquid U. A colorless gas was given off and a white precipitate was seen. The precipitate was not T. What could be the identities of T and U? Solid T was placed in an excess of the liquid U. A colorless gas was given off and a precipitate was seen. The precipitate was not T. Okay. Liquid U. B.
B is in boy, right?
Yeah.
Correct. Okay.
Wow. पेपर में तुक्के क्यों नहीं सही होते हैं?
पता नहीं इसके लिए जब आपके पेरेंट्स भी कहते हैं ना तो मुझे समझ नहीं आ रहा था she is doing so great at my class why is she not doing great at the papers well you eventually get better don't worry so never lose hope about it sometimes the starting papers of A-level come with a huge dip yeah the grades fall by 1 or sometimes by 2 or 3 steps even but never get disappointed with that because that's the infamous first result dip for A-level. So I said the same thing to your parents. So never get disappointed by that. You would see that closer to the papers, you will perform much better and with a better grade as well. So keep going. Keep doing the hard work. Keep staying attached to the book. Keep practicing more and more. And you'd see eventually everything changes.
Yes, sir. Sir, I can't hear you.
I was thinking you must be doing the question number 12. That's why I stopped talking.
Okay. Oh, calcium forms an ionic compound with carbon called calcium carbide. The oxidation number of carbon in calcium carbide is -1. Calcium carbide is really hydrolyzed by water, giving two products only. What could be the formula of calcium carbide and the two products of hydrolysis? Forms an ionic compound with carbon called calcium carbide. Oxidation of carbon is -1. Carbon -1, this would be +1. CaC2. So it can either be C or D, and then it's readily hydrolyzed by water, giving two products only. CaC2 plus water gives us CaO plus H2, C2H4. C2H2. 2 plus 2, 4. Then 2, 2. D.
D, very good. Let's skip 13. 14 is too easy. Since we are already done with 14 as well. 15. Let's go with 15.
Elements J and K react together to form compound L. Elements J and K are both in period 3. Element J has the smallest atomic radius in period 3. There are only 2 elements in period 3 which have a lower melting point than element K. Which compound could be L? React together to form compound L. Both in period 3. J has smallest atomic radius in period 3. One second, sir. Radius increases as the smallest nucleus as the smallest magnesium, sodium, and phosphorus. So like phosphorus has the smallest atomic radius, which have lower, there are only 2 elements in period 3, which have lower melting point in period. D.
D is in boy or D is in door?
Door.
Correct. Good. 16.
Which oxide, when mixed with water, will produce the solution with the lowest pH? When mixed with water, will produce the lowest pH. Carbon dioxide gives us and then Na2O plus H2O, Na2O, no, NaOH. Then P4O10 gives us phosphoric acid, H3PO4. Silicon oxide reacts with water. I don't think fraction of that. So it's at the lowest pH. Lowest pH means acidic.
Right.
So C.
Right. Good. C. You're right with C, but there is something you need to understand. When you're talking about lower pH and acidic, you can't probably think about basic oxides. So even any calculations regarding B and Na2O would just be a waste of time. Try only going with known metals since we're talking about lower pH and not a higher one. All right.
Yes, sir.
Moving on. 17 is too easy. 18 is easy, but let's go with it since I guess this is the first time you're working with lime mortar.
Lime mortar.
So go ahead.
Lime mortar is made from quicklime, water, and sand. Over a period of time, lime mortar changes into a much harder form. Both fresh and old lime mortar react with aqueous hydrochloric acid, but only the old lime mortar effervesces during the reaction. Which equation describes the change from fresh to old lime mortar? It's made from quicklime, calcium oxide, and water, and calcium silicate. Sand, calcium, and sand. Okay. Over a period of time, lime mortar changes into a much harder form. Both fresh and old react with aqueous hydrochloric acid, but only the old effervesces during the reaction. Which equation describes changes? both fresh and old react with aqueous hydrochloric acid, but only the oil freezes during the reaction. It's made from quicklime and water. B.
B.
B for ball.
No, I don't think that is right.
React with hydrochloric acid, but only the.
Okay, don't forget that it is going to turn into a much harder form. That's the very first line. All right,
Yes.
and much harder form should be solid. So
So
try going for a
calcium.
solid product. So your only options can be either A, C, or D. B can never be the option. B is not a solid product.
D.
D, very good. And why D?
First, because they said harder form to solid होना चाहिए, and then it reacts with aqueous hydrochloric acid, but only the old lime freezes during the reaction. So, the
Full का मतलब है कि D आंसर ठीक है. CaCO3 produces carbon dioxide and effervescence. CaO's choice does not produce a gas, so no effervescence. Make sense? You were right with D. ठीक है? D actually completes everything that is given in the statement. They say they start with quicklime and water. This is quicklime and water forming COH twice. Now, the tricky part is that the CH twice is written over here, right? Over a period of time, much harder form can be CaCO3. CaCO3 is the hardest solid among over here. Since the CaCO3, the CaO, and the CaCO3 are your options, this one is the hardest one, right? Now, when it becomes old, it reacts with aqueous hydrochloric acid and produces effervescence because this produces carbon dioxide in old form, and this does not produce a gas. So everything written over here goes for D in D alone. Make sense?
yes, sir.
Great. And I guess